about these as we go through. We're going to go through the first one, okay? So I'm trying to learn your name too, so you're just going to have to tell me your name when I ask you. So what's your name? Whitley? Whitley, what's the first answer? Why? How do you do it? Show me 3 plus 2. Good. What did she do? She showed me 3 fingers on one hand and 2 on the other. That's a very good representation. This is called counting when we're adding, right? We just count. We have 3 of the fingers and 2 more fingers. We're just counting fingers, right? So that's very good. Okay? So that's how we do 3 plus 2. What's this one? What's your name?
Addison.
Addison, what's this one?
5x.
Are you sure it's not 5x squared? How come it's 5x, Addison? Right, you're not multiplying, so you don't do anything with the exponents. That's super important. I might write that off to the side. When adding like terms, don't change exponents. When adding like terms, don't change exponents. I'd write that out to the side there. Okay? Now, show me 3x plus 2x. She did the same exact thing. What are her fingers representing? X's. This is an X, this is an X, this is an X, this is an X, this is an X. How many X's do I have? 5. It's very simple, right? So this one is almost the same as the top one, it's just that you're counting X's. Okay? So as long as these are like terms, you don't play with the exponent, you only add the coefficient. Now that's a word you need to know that I'm going to use a lot. Do you understand the word exponent and the word coefficient? What's an exponent? What's an exponent? Who can answer that? What's your name?
Wait, what?
What's your name?
Isaac?
Isaac? What's an exponent?
I don't know.
You don't know what an exponent is?
No.
Who knows what an exponent is? Ready? What's an exponent? What's your name?
Matthew.
Matthew, what's an exponent?
A letter.
Is a exponent a letter? He's actually close, but it's not quite that. It's a number where? Yeah, it's to the right and raised to a power of an exponent. Okay, these powers are all what? Exponents. There's a lot of exponents on this board, right? What if it doesn't have an exponent? What is the exponent on that x?
1.
1. Okay, so this is actually a 1. This is actually a 1. This is actually still a 1. That's why I asked her, are you sure it's not 5x squared? Because a lot of kids, what do they want to do? Add the exponents just like they added what? The coefficients. But remember this is something I want you to write in your notes out to the side. The exponents are a step behind the coefficients. The exponents are a step behind the coefficients. So notice I added the coefficients, but I did nothing to the exponent. That's going to come in handy as we go through these. What's this next one? Okay. What's your name?
Jax.
Jax? Jax, what's 3 times 2?
6.
Why?
That's 3 twice is 6.
Good. I like how he said that. Say that again, Jax, really loud.
3 twice is 6.
3 twice is 6. Did you multiply then, Jax? No, you didn't. Yet you did. Right? Multiplication is truly addition. Let me give you an example. My grandpa never knew how to do multiplication tables, and yet he could do them faster than I could. 8 times 7. This is what he would do. Well, 3/8 is 24, and 2 sets of 3/8 is 48, and then 1 more 8 would be 56. Did you follow what I said right there? 8 times 7. My grandpa would say. Well, 3/8 is 24, 2 sets of 3/8 is 48, and 1 more 8 is 56. That's 8 times 7. Does he know how to do multiplication? Nope, my grandpa doesn't do any multiplication. He does strictly what? Adding groups or sets, just like Jax just said, right? I have 2 groups, or two sets of 3, I'm adding them together, that's how I get 6. That's what 3 times 2 means. We oftentimes don't think about the meaning behind the math, but I would submit to you that that's the purpose of math, is to think about the meaning behind the math. We worry about the answer, 6, right? But we really shouldn't worry about the answer. We should worry about what? How we get there. What does it mean? Okay, so I want you to ask that a lot. How did I get there? What does it mean? As we do all the math throughout this whole class, right? Keep asking that question. All right, what's 3x times 2x then? Is it different than 3x plus 2x? It's different, right? Okay, what did you get? What's your name?
Okay.
Cade?
Okay.
McCade?
Yeah.
Okay, so McCade, what's this going to give me?
6x squared.
Good. How come you put x squared?
Because it's multiplied.
Okay, so what did you do with the exponents? Remember, this exponent was 1. This exponent was 1. How did you get x squared?
Added together.
Ah, what did you do with the coefficients?
Multiply them.
Ah, that's where people miss it. This is the most missed problem, or type of problem, on the ACT. Why is it missed? People want to do the same thing with the coefficient that they do with the exponents. They want to multiply both. I see 6x on that one a lot. But it should be 6x what? Squared. You shouldn't multiply the coefficient and multiply the exponent. You treat them differently. The exponent is a step behind. Are you with me on that now? I multiply the coefficients, but I what the exponents? Add them. Are you with me? And I might write that out to the side of that one, because that's going to be important. You multiply the coefficients, you add the exponents. It's a step behind every time. You're going to see that even more with the next one. Okay? So the next one, what's it going to be? It's almost similar. It's very similar. Lindsay, what do we get on this one?
6x to the 7th.
Okay, so 6x to the 7th. What did she do with the coefficients? What did she do with the coefficients? That's the numbers in front of the variable. Multiplied them. What did she do with the exponents? Added them. See how they did different things with them? That's where kids mess up, is you try and do the same things with them. Don't do the same things. Treat the exponents differently than the coefficient. That's really the key to this whole chart. Okay? All right, let's try the next one. This is a little different than these up here, right? What's your name? Allie? Okay. Allie, what do you think this one is?
I got 3x
3x to the 5th. Is she right? She can't be right because she did what with the 2 and the 3? Added them, and that's what we do when they're multiplied. This is a power to a power. Can you see that? So I've got to go in the next step, right? Instead of add these, what do you think I should do? Times them. So let's times them. We should get x to the what? 6th, right? So I have an x to the 6th. So that's the exponent part. What does 3 squared mean? Addie, is it Addie? Or Allie? I can't hear you. Isn't that stuff? Is it Allie or Addie? Allie, okay. Sorry, because we got the drilling and the stuff outside too. Okay, so what does it mean, Allie?
3x's.
What does 3 squared mean?
3 of them.
Does it? What does 3 squared mean? Who thinks they know? What does it mean?
I mean, you have 2
2 threes what, though? What am I going to do with the 2 threes? Times them. That's the key. Up here, we had 2 threes, but we did what? We added them, but now when we have an exponent here, we're going to have 2 threes, but we're going to times them. So 3 times 3 is what? 9. By the way, I could break that down even more and write 3 plus 3 plus 3. Right? 3 plus 3 is 6, plus 3 more is 9. 3 sets of 3. See? So that's how that works. Okay, 9x to the 6th. Again, coefficient multiplied to itself twice, 3 times 3. Exponent multiplied, 6. Okay? Let's try the next one. So this is pretty complicated. Let's break this one down, first part, and then we'll do the second part with it. Okay? So we're going to break it down. Alejandro, just think about this part then. What's 2 squared?
4x to the 6th.
4x to the 6th. How did he get the 4?
Times 2.
2 times itself, because I have it twice, okay, give you the 4. And then x to the 6th, what did he do with the exponents?
Times those 2.
Times those two together, so he has x to the 6th. Okay. Then we're going to multiply that to 3x. Now what do we get on this side? What should I do with the coefficients?
Times
Times them. 4 times 3 is
12.
12. What should I do with the exponents? That still has a 1 on it, even though there isn't anything there. What should I do with those exponents?
Add 'em.
Add them, I should get x to the what?
7.
7. Everybody got it? It's kind of complicated. That was a hard problem. Again, I notice how I broke it in parts. By the way, when you solve problems in life, right? One of the great techniques that math teaches you is to break it into parts. Okay? Kids who commit suicide, honestly, this is an issue. They don't know how to problem solve and they don't know how to break things into parts. Right? Because what happens is they get all caught up in the big problem that they see, and then they're like, oh, I can't handle it anymore, right? It's sad. It's a really bad thing that happens, but it's because they don't break it into parts. If I say, oh, my girlfriend dumped me, oh, I'm screwed. Well, break it into parts. All right, she dumped me. Are there other girls in the world? Yes, right? So, am I going to survive this? Yes. Yes, it hurts now, but it's not the end of the world. There's a lot more to life than just one relationship. See, but when you're in the bubble, if you just look at the problem, you can't break it down into those smaller parts and thinking about what's outside of those parts. We have to do that. That's what math does. You have to say, look, I got coefficients that I need to deal with. That's true. But I also have exponents that I need to deal with. I'm going to take them one at a time. I'm going to do the coefficients, then I'm going to do the exponents. Don't try and get all caught up in the big problem, then you'll get all confused. You need to think, break it into pieces, take it one step at a time, and it'll be all right. Okay? And that's the same thing in life. Try and break it into smaller pieces, fix those pieces, and then go on. Anybody do mechanics or anything like that? Fixed anything in your life? That's what you do. You figure out what's wrong. Okay, here's the big problem. The baler isn't working. Okay, well, what's not working on it? Well, it's not tying the bales. Well, okay, so I don't have to fix the whole baler. Obviously, the PTO's working. I don't have to worry about that. What do I got to worry about? I got to worry about the tire. Why is it not tying? Oh, well, here's the part. Well, I'm going to have to fix that one part. It doesn't mean you throw the whole thing out. Okay, that's the same thing, like I said, in life. You don't just throw the whole thing out. You just fix the part. Fix what's broken. Okay, but you got to identify that, looking at the big picture, but then narrowing it to smaller pieces, just like we do in math. That's why I say math isn't something you use every day, but the problem-solving skills you learn in math is something you'll learn every day. You'll use every day. Break things into smaller parts and pieces. Okay. All right. What's the next one? So think about what's happening. Am I multiplying or am I raising a power to a power? What's your name?
Jesse.
Jesse. I've had you before, haven't I?
Yeah.
Okay, so Jesse, am I raising a power to a power on this one, or am I just multiplying?
I think you're just multiplying.
I'm just multiplying. So what should I do with the exponents?
Multiply them.
So think up here. What did I do with the exponents when I was multiplying? I added them, right? So what should I do with all these exponents?
Add them together.
Add them together. So what do I get?
9.
9. That's it. Okay? So again, I identify the problem. The problem is saying I am just multiplying. Once I identify that, then I think, okay, I've already seen this before. Right here, what did I do when I was multiplying with the exponents? Oh, I added them. Therefore, right here, all I'm going to do is what? Add them. Okay? What's this one now? We just said with Jessie, she said this was just multiplying, so I add them. What's this one do? What's your name?
Trinity.
Trinity? Oh, I know you too. It's just all these maps. I can't see your face, so I can't see it. So Trinity, what are these doing? Are they multiplied together or are they raised to powers? They're raised to powers. Have we seen that before? Yeah, what did we do with the exponents right here when they were raised to powers? We times them. So what should I do with all of these numbers? Times them together. So what's 2 times 3?
6.
Times 4? 24. Okay, so this is x to the 24. Again, I broke it into pieces. I thought about it. What is it asking? And then what should I do based upon what I've already seen? Right? Way simple. Okay? A little bit trickier because we have both a coefficient and an exponent. We've got to treat them differently. Okay? So just take the 2. Just take the coefficient. Okay? What's your name again? I'm sorry. Red shirt. Not Trinity. Who's sitting behind Trinity? Matthew, sorry. 2 red shirts in a row. That's not good. Okay, Matthew. 2 is being raised to what powers then?
3.
It's being raised not to that 3. That's a mistake a lot of kids make. So that's a good mistake, Matthew. So he said it was 2 to this third. Is it really 2 to that third? No, the 2 is not raised to the third. The x is to the what? Third. The 2 is going to be raised to the 2 and the 3. So I've got, think about this, I got 2 to the second raised to the third. What should I do with those 2 exponents? Exponent raised to exponent, what should I do?
Times one.
Times them. It's either add or times, right? And I got to times them. So what does this give me? 2 to the 6th. What is 2 to the 6th? Think about it like my grandpa does. 2 2s is what?
6 times.
2 2s is 4. 3 sets of 4. Well, that would be adding, but he's got to multiply. So you got to multiply. So you got to think about that as 4 times what? 4 times what? 4. 4 times 4 is? 16 times 4 is? Or 4 16s. What's 2 16s? 32 doubled 64. Okay, so this is 64. Okay, that's the coefficient. Notice all I've done is the coefficient. So the coefficient part is 64. Okay? Now, let's look at the exponent part. Okay? I forgot your name.
Matthew.
I'll get it, Matt. Do you go by Matt or Matthew?
Matt.
Matt? Okay, so Matt, what am I going to get with the exponents? What should I do with them? Times them together. So 3 times 2 is? 6 times 3 is? 3 6s. 6 and 6 is 12. 6 more is? 18. So I'm going to go x to the 18. Okay? X to the 18. Okay. All right, next one. What's your name?
Isaac.
Isaac? What is happening with all these x's? Are they power to power, or are they multiplied, or are they added?
They're adding.
I'm going to add them, but they're being what? Multiplied, right? I'm going to add the exponents because they're being multiplied, okay? Because they're a step behind. So I'm going to add all these exponents together. So Isaac, what's 2 plus 3?
5.
Minus 3?
2.
Plus 4?
6.
Minus 5?
1. 3x.
It's just x. 3x. That's the answer. How come I just have the 3? What's the coefficient here? What's the coefficient here? What's the coefficient here? What's 1 times 1 times 1 times 1 times 3? 3. Right? What's 1 times 1 times 1 times 1 times 1 times Isaac? Isaac, right? It's the identity. It's whatever you start with, you get the identical thing back. If you start with Isaac and you times him by 1, you still get Isaac. Right? If you start with 3 and you times it by 1 a lot of times, it doesn't matter. You're still going to get just 3. Okay? Let's try this one. Okay, this one's pretty easy. Now we're going back to easy. Brody, what do we get when we get 2 to the third?
8,
Why is it 8?
because you go 2 times 2 times 2.
Right, it's 2 times 2 times 2. Remember, it's multiplying it to itself 3 times. A lot of kids want to write 6 here because they want to multiply those, right? But that's not right. It's 2 times 2 times 2, which is 8. Now, here is the super tricky one. It's the next one. If you have a calculator, this is pretty easy. But if you don't have a calculator, it's kind of tough. What's your name again?
Autumn.
Autumn, what's the next one?
Is it 1/8?
It is 1/8. Most kids mess that up. You're pretty smart there, Autumn. Okay, how come it's 1/8? This is something you want to write in your notes. So out to the side of this one, I would write this. A negative exponent makes nothing negative. Okay, a negative exponent makes nothing negative. It just reciprocates it, meaning it goes from top to what? Bottom, or from bottom to top. And when we get to this one out to the side, that's what we're going to do. Okay? It reciprocates it. It takes it from top to bottom, or bottom to what? Top. Okay? So that's all the negative exponent does. Let's think about this for a second. What's 2 to the first? What's 2 to the second? What's 2 to the third? What's 2 to the fourth? What's 2 to the let's see, 2 to the second, 2 to the third. What's that equal to?
Well, no.
2 to the what? What should I do with those exponents? 2 to the fifth. How come? Multiply together. What did we do with the exponents? Add it. See how we can use this chart of destiny to help us figure out what this is saying? Exponents should add. So 2 to the fifth is, what is 2 to the fifth?
32.
32. What did I do here? I added the exponents. Everybody agree with that? Okay, now watch. This is where it gets kind of interesting. We're going to leave this one blank for now. What's 2 to the negative 1?
1/2.
1/2. What's 2 to the negative 2?
1/4.
Do you see the pattern? 2 to the negative 3? Ah, you're seeing the pattern. What's 2 to the negative 4? 1/16. All it's doing is taking those to the denominator, right? Now, I want you to think about this. What's 2 to the third times 2 to the negative third? 2 to the what?
0.
What's 3 minus, good. It is 2 to the 0. Now, what does 2 to the third mean? What is it? 2 to the third is 8, right? You guys just said that. What's 2 to the negative third? What's 8 times 1/8?
0.
Nope.
1.
It's 1, because the 8's divide out. 1 over 1 is what? 1. So 2 to the 0 is? Anything to the 0 is. Watch this. What does that equal?
Start to 0.
Start of the 0. This is start of the 7. But this is what? How can I make that positive? 1 over start of the what? 7. What happens with the start of the 7s? And what's my answer? Anything to the 0 is what? 1. Because when you add these exponents, it's going to always create a 0. When you multiply the reciprocal, it's always going to create 1. So anything to the 0 is 1. Just kind of interesting side note there. What is x to the negative 3 then with positive exponents? What's your name?
Tyson?
Tyson. What's x to the negative 3 with positive exponents? 1. I want just this to be exponent positive though. What will I do with that x to the negative 3?
Flip it.
Flip it. So it's 1 over what? X to the third. Okay, that's all I wanted you to do on that. What's your name?
Destiny.
What is it?
Destiny.
Destiny. Make all the exponents positive in this problem.
Move the 4 to the bottom.
Move the 4 to the bottom. Move the 3.
To the top.
Leave everything else, right? Okay. What's the answer then, Destiny, on the top? Just on the top, right there.
X to the 14.
I got x to the 14. What did she do with the exponents? Added them. Very good. What about the bottom, Destiny?
X to the 11.
Which will be x to the third. How come it's x to the third? What does x to the 14th mean? What does it mean?
There's 14.
14 x's multiplied together, right? So on. Okay. What does this mean?
There's 11 X's.
There's 11 x's times together. Whatever, okay? So I take these 11 and these 11. How many's left on the top? 3. Really, you subtracted those, didn't you? But I don't like you to think of it as subtracting. Just think about it as dividing them out, okay? Now, is there another way to do that problem? What's another way to do that problem? So I made everything positive, then added the top and added the bottom and then subtracted the bottom from the top. What's another way to do it?
You just subtract the -4 from 5.
Okay, I can just do the top. I don't have to switch anything. He says I can just add straight across. Is he wrong? He's not wrong. Add straight across. -4 plus 5 is? 1 plus 6 is?
7.
And then he did the bottom. And then he subtracted the bottom from the top. Is he going to get the same answer? Totally fine. 2 ways to solve a problem. 2 ways to talk to parents, right? There's more than one way. Don't get freaked out if we show you a different way, right? Do whichever one seems more comfortable to you and makes the most sense, okay? If it makes sense to you to just go straight across the top, straight across the bottom, and then reduce, that's fine. If it makes sense to you to make everything positive first, because you're a positive sort of person, that's fine. What else could you do? You could just bring everything up to the top and add them all together. Right? Bring everything to the top and add them all together. So in other words, still the same problem. I have x -4, x5, x6, then I'm bringing these to the top. Sorry. x3, x what? -7. Add them all together. -4, 5 is 1, 7. 7 and 3 is 10. Minus 7 is 3. Done. Is one of those ways easier than the other? Maybe for you. To me, they're all about the same, right? There's really not much difference. But one way is going to be best for you. I don't know which way that is. Bringing them all up to the top and just adding them straight across. Okay? Adding all the tops, adding all the bottoms, reducing. Making everything positive, then reducing. I don't have to deal with any negative numbers, right? Which is nice. So all 3 of those ways can be done. You just have to decide which way is best for you. Okay? All right. So that's all of them. Everybody got it? Okay, stop that for a second.